Alrighty, so this is the second of 4 videos that I'm going to post this weekend that basically cover the 4 problems that we graphed on Friday in class. So if you were absent, you'll have a chance to catch up on these problems. Again, if you didn't watch the first video, print out one of these forms on my blog and then follow along or try the problems and then check back to this video to see if you graphed it correctly. So this second function is y equals negative tan of x minus 2. So just like the other problems, we're going to ask ourselves these 5 questions before we graph. So part A, the parent function is just y equals tangent of x. Is there a reflection? Absolutely. We see our a value here is negative, so yes. And again, once I see a transformation, I'm going to highlight it to remind myself to make that transformation. Is there an amplitude change? Now technically we talked in class that tangent doesn't have an amplitude because it extends from negative infinity to infinity in the vertical direction. But if we looked at is there going to be a vertical stretch? No, because we still have a negative or a 1 in here. It's just been reflected. Is there a horizontal shift? No, that would be within the parentheses on x, so there's no horizontal shift. But we do see here this negative 2 is our k value, which is going to drop our whole graph down 2. So yes, there was a vertical shift down 2 units. So it looks like we only have 2 transformations to perform on our parent function. So the first thing, like we've done with the other graphs, is we graph our parent function of tangent of x. So in class what we did is we took out our big graph of tangent that we made on Tuesday and copied that down here. So as a reminder, remember tangent has some values where it's undefined. So tangent sine over cosine. So every cosine is equal to 0, which are multiples of pi over 2, 3 pi over 2. Tangent's going to be undefined. So this is where we graph our asymptotes. So that's where I'm going to start. Sketch in my asymptotes. Every multiple of pi over 2. After we've got our asymptotes, the next easiest place or point graph are where tangent's going to be equal to 0. So that's going to be where sine is equal to 0, which is every multiple of pi. So in this case, here at negative 2 pi, pi, 0, pi, and 2 pi. Then to at least graph a couple other points within each period, I kind of am biased, but we talked about in class that to find multiple pi over 4 or odd multiples, pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4, tangent's equal to 1 or negative 1 at these values. So in this case, these were probably our optimal points to graph if we were to choose at least 3 points on every period. So if I do that, pi over 4 would be here, so let me mark off where 1 would be. So at pi over 4, we'd be at 1. At negative pi over 4, we'd be at negative 1. Then if we connect those and we approach our asymptotes, we see how it curves through those points and approaches our other asymptotes. So we see here that complete one period of tangent only takes pi radians. So our period is going to be pi. So if I repeat that at all our quarter marks here, we see this repeated pattern. These graphs take a lot of work. We've come away since just graphing lines, so we have to be patient and very neat about our work. So there we've all been far is just graphed our parent function. So I'm going to graph the next 2 in a color so we can see. So if we were to reflect everything over, our asymptotes stay put, everything just reflects. So this point that was at 1 is going to move to negative 1. Any point that's on 0 obviously can't reflect. So if we reverse the direction of these s's by reflecting those 2 points that we just graphed, we see that our reflection looks like this. And again, feel free to pause the videos, stop the videos, rewind the videos if you feel like something's moving too fast. I'm going fairly quick just because we did this in class and you have that control when you watch these videos to slow it down or to rewind. All right, the last thing we're going to do is we're going to vertically shift everything to. So in this case, our asymptotes, obviously, if we shifted those, they're not going to change position. But we see here that if we take these s's and move them down, we can just take our key points here that we graphed and move them all down 2 units. So this point here that was at 0 is going to get dropped down to -2. This point that was at -1 is going to get dropped down to -3, which would be right here. So 1 goes down to -1, 0 to -2, -1 to -3. And there we have it. So just repeating all of this for each one of these graphs, or I should say periods. All right. And there we have our final graph for y equals the negative tan x minus 2. Oh, real quick before we go on, our range is all real numbers. Our domain, this actually took a little bit longer conversation. We saw that our domain were in these pieces. So a couple ways to describe it, probably the best we looked at it was basically our domain were all real numbers except for these asymptotes. So we said all real numbers except, and then we had to look at where our asymptotes are right now. Right now they're at all our odd multiples of pi over 2, so 1 pi over 2, 3 pi over 2, -1 pi over 2. So we said for every multiple we used n pi over 2. So that basically means any multiple of pi over 2, and then where n is an odd integer. So 1, 3, 5, and so forth. Amplitude, no finite amplitude. We can vertically stretch it, but there's no minimum or maximum value. And our period is how long it took to repeat one of these curves. So we see that between the two asymptotes, they're pi radians. So our period is pi. Alrighty, there's number 2 of 4.